Okay, welcome to graphing cubic and quartic polynomial functions. These are the 3 steps. So we need to find the zeros, the x-intercepts, and plot. And usually we do that by synthetic division and factoring. And then setting those factors equal to 0, which we've been practicing a lot. So you're really good at that. And then also we're going to find the y-intercept. That means we're going to plug in 0 for our x's and then solve for y. And then we're going to sketch the end behavior. So for end behavior, let's just review that really quick. What it comes down to is the largest degree or highest degree that you would see and the leading coefficient. So for example, if f of x was equal to negative 10x cubed minus 50x squared plus 49, the highest degree would be 3. So the highest degree is 3, and that is an odd. So your options are odd or even for your degree. And your leading coefficient is the number in front of your highest degree. So that would be negative 10. And your options there are either positive or negative. Right. So depending on where it's whether it's odd or even or positive or negative, that will change your end behavior. So we'll do an example. So if we had, we'll do even. So even follows parabolas. So if we had f of x equals 5x to the 4th plus 3x squared plus 1. Again, we're just sketching the end behavior. We'll actually find our zeros for different examples. But we know that this is even, since the 4 is even, and we've got our leading coefficient of 5, which means that's positive. All right, so it's going to be up like a cup, just like maybe something like that. Let me draw. So if I put it on a coordinate plane, again, I'm not sure where the zeros or the y-intercept is, but your end behavior is up like a cup, just like a parabola would. We just got done graphing a bunch of quadratics, so it's very similar. Okay, and then the other option for even would be the coefficient of negative. So if I had f of x equals negative x to the 4th plus 3x squared plus whatever, our degree would be even, and our leading coefficient is actually negative 1, and that would be positive. Or no, not positive, negative. All right, so just like quadratics, that's going to go down like a frown. So our disregarding x and y intercepts, our end behavior is going to start down and end down. Okay, so those are your options if it's even. All right, now we'll do options if it's odd. So if I have an example, f of x equals 2x cubed plus 5x plus 1, my highest degree, so my degree is odd. My leading coefficient of 2 is positive. Okay. So it's going to follow a positive slope, just like if you graphed a linear equation that starts low and ends high. So this one is going to start low, so it's going to start right here, go through somewhere on the x and y axis, and then it's going to end high. So it follows, we read a graph from left to right, so it's going to follow a positive slope, just like if you graphed a linear equation with a positive slope. So our little guy is going uphill. Right? The other option, so you only have 4 options. The other option, for example, we have f of x equals negative 10x cubed plus 3. Okay. All right, so our degree again is odd. Our leading coefficient of -10 is negative. So that's going to give us the end behavior. And that's going to follow a negative slope where it's going to start high, go through something, and end low. Right? And it follows, just if you graphed a linear equation with a negative slope, our little guy is going to go downhill. Right? So that's all about end behavior. And then let's graph a few examples. All right, so we're going to find the zeros and sketch the graph. So we have, so our goal, let's look back at our steps. Our steps would be to find the x-intercepts, find the y-intercept, and then use the end behavior. So we're going to find the x-intercepts. Put that up here. Now, if you can do all of this, then go ahead and pause the video and graph it, and then you can fast forward this part. But let's see. So when we find x-intercepts, we know 1, 0 is -1. So I'm going to draw my thing. All right. And then I'll put the coefficients. We have 1, -2, -1, and +2. And then I'm going to drop down the 1, multiply, get -1, add to get -3, multiply to get +3, add to get +2, multiply to get -2, and then this is 0, which means it is a factor. It's 4 terms, and I can also factor by grouping, but I'll stick with this. So we have 1 degree less, so x squared minus 3x plus 2. And I want to set that equal to 0 because I'm solving for all the x-intercepts. So when I graph it, I get x minus 2 and x minus 1. Right, I set those equal to 0. And so I get x equals 2. I get x equals 1. And then I also get this x-intercept. So x equals -1. Okay, so those are my x-intercepts. My y-intercept, let's see. My y-intercept, remember I'm going to plug in 0 for x. So I get 0 cubed minus 2 times 0 squared minus 0 plus 2. So my y-intercept, when I plug in 0, I get 2. And then I want to look at my end behavior. And then I'll put it all together and sketch the graph. So my degree, again, options are even or odd. My degree is odd, because that's the largest degree. There's technically nothing in front of that, so we'll call that a +1. So my leading coefficient is positive, which means I'm going to start low and end high. So I'll put all that together. So I'm graphing my x-intercepts of +2, +1, -1. My y-intercept is +2. And then I'm going to use my end behavior to sketch the graph. So I start low. I go through the first x-intercept, through the y-intercept, down to the other x-intercept, and then up through the last x-intercept, and that is my graph. We are done. All right, the next example is we're going to do the exact same thing. So we're going to find our x-intercepts, our y-intercept, and sketch the end behavior. So if you can do this all by your lonesome, go ahead and pause the video and then fast forward to make sure you have the answer. All right, so let's see. I want to find x-intercepts. Given that this is a factor, so it's not a 0 yet. So if I were to solve for the 0, I subtract 3 and I get x equals -3. So -3 will go on the outside, and then my coefficients are 3, 10, -3, -20, and -6. All right, so I drop down the 3. I multiply to get -9. I add to get 1. I multiply to get -3. I add to get -6. I multiply to get +18. I add to get -2. I multiply to get +6, and then this is 0. All right, so I have 1 degree less, so this is going to be 3x cubed plus 1x squared minus 6x minus 2. So I have 4 terms, and I don't know any other factors, so I'm going to hope that it factors by grouping. So I'm going to split this up. I'm going to pull out what's common. So out of 3x cubed and x squared is common. And then inside we'll have 3x, since x squared times 3x is 3x cubed, and then plus 1. So x squared times 1 is x squared. And then here I have a negative 6x and a negative 2. So what's common is 2 or negative 2. I'm going to factor out a negative 2 so I can get the same thing inside. So that would be a positive 3x and a positive 1. Right? And then I'm going to factor out the 3x plus 1. So I only take one of them. That goes on the outside, and then these two go inside in another separate parenthesis. And so that is factored. And then I have some more work to do. So I'm going to set each factor equal to 0. And then solve for my other x-intercept. So here I'll subtract 1. So I'll get 3x equals negative 1. Divide by 3, and x equals negative 1/3. And then for this one, I'm going to add 2 to both sides. So I get x squared is equal to 2. When I square root both sides to get rid of the square, x is going to be plus or minus the square root of 2, which is actually, if you put that in your calculator, it's plus or minus 1.4. So my x-intercepts are negative 1/3, a positive 1.4, a negative 1.4, and then the other one that I used was negative 3. Okay, so we'll come back to those when we graph. The y-intercept, when I plug in 0 for x, I'm going to get that last number of negative 6. And then my end behavior, which we'll do down here. My end behavior, so I have options are positive, or even and odd, and this is a even function. And 3 is positive. My leading coefficient is positive. So just like a quadratic, it's going to start up and end up. All right, so now that I have all that, we'll graph. So negative 6 is right about there. And then we have x-intercepts of the original one that they gave us, negative 3. We also have negative 1/3, which is between 0 and negative 1. We also have negative 1.4, which is between negative 1 and 2, and then positive 1.4, which is between 1 and 2. All right, so with all of those graphed, now I can start my end behavior. So I'm going to start up, go through these x-intercepts, go all the way down to the y-intercept, and then come up through that last x-intercept. And that is my graph. Now if you graphed it like this, that would be okay too. And don't worry, our last example, we are going to graph this one. Okay, so they give us that a 0 is 3, so I'm finding my x-intercepts, my y-intercept, and the end behavior. So I'm going to put 3 outside, and then inside it's going to be negative 4, 20, negative 23, negative 5, and a positive 6. So I bring down the negative 4, I multiply to get negative 12, I add and get 8. I multiply to get positive 24, I add to get 1, I multiply to get 3, I add to get negative 2, multiply to get negative 6, and so it definitely is a factor, or a 0, because the remainder is 0. And then I write what I have left. So it's 1 degree less, so I have negative 4x cubed plus 8x squared plus x minus 2. So it is 4 terms, so I want to factor that by grouping. All right. So what's common to negative 4x cubed and 8x cubed is a negative 4x squared. So inside I would get x minus 2, right? Because negative 4 times negative 2 is that positive 8. And then I don't have anything to factor out, so like today in class, you factor out a 1, and then inside you will have x minus 2. So I'm going to factor out that x minus 2, and then the other parenthesis will contain the 2 outside numbers, negative 4x squared plus 1. Right, and that equals 0. So my x-intercepts, I have x minus 2 equals 0. I have negative 4x squared plus 1 plus 1 equals 0. So when I solve, I add 2 to both sides. I get x equals 2. This one, I subtract 1 from both sides. So I have negative 4x squared equals negative 1. When I divide by a negative 4, a negative divided by a negative is a positive. Okay, and then to undo the square, I have to square root both sides. So I have x is equal to plus or minus. Again, I can split this up. This is the square root of 1 over the square root of 4, and that would be 1/2. So plus or minus 1/2. So my x-intercepts are 2, a positive 1/2, a negative 1/2, and the original 0 they gave us, which was 3. Okay. All right, so we'll come back to those. And then the y-intercept, when I plug in 0 for x, I'm going to get all of that is going to add up to 0. So it's going to be 0 plus 6, so my y-intercept is 6. And then my end behavior, so I have, again, degree is going to be even or odd. Those are your options. And since 4 is the highest, and that's an odd number, where do I want that? Degree is even. And then my leading coefficient of negative 4 is negative. Okay, so it's going to go down like a frown, just like a parabola would. All right, so I sketched all that. So my x-intercepts are positive 2, positive 3, positive 1/2, negative 1/2, and I have a y-intercept of positive 6. All right, and then I use my end behavior. So I'm going to start with the negative 1/2 x-intercept, go up to my y-intercept, down through my other x-intercepts. All right, and that's my end behavior. So that is the end of the video, and I will see you tomorrow in class.